Hi, welcome to INF313, Introduction to Computational Reasoning. My name's Dan Ryan. I'm a professor at the Faculty of Information at the University of Toronto. So, what is computational thinking? What is computational reasoning? Well, on the one hand, it's defined as a style of thinking that facilitates the discovery and expression of solutions that can be implemented on automatic computing machines. On the other hand, the term refers to a set of concrete tools and cognitive moves, if you will, that are things you learn in computer science, but that are actually super useful in all kinds of situations faced by modern problem solvers. The course will make connections between computer science and ideas you've learned in other contexts, and in everyday life for that matter. And it will enhance your capacity and your confidence to work with folks who have more technical chops than you do, as well as providing a foundation for your own further upping of your technology game. The student for whom the course was designed is a budding thinker who works or will work in or near digital technologies. That is, everybody. She has training in the humanities, the social sciences, or perhaps the natural sciences that can be leveraged by focusing on continuities between those fields and computer science. So where will we go on this journey? A really important problem at the intersection of technology and society is the AI alignment problem. How can we ensure that artificial intelligences that we build pursue goals that are compatible with what humans want?
To do the same thing. If you want unlimited intelligence, you have to solve value alignment. So my claim is that in the future, we will be able to design super intelligent machines that do exactly what they're supposed to do, which is to support greater realization of human values. And I think this is maybe the most important conversation that we can have over the next 50 years. Thank you.
Our goal is getting to the point where we're able to converse confidently and competently about things like that. We'll structure the course as a learning journey from wherever you are to that goal. We'll start with foundations. At our first stop, we'll learn to think slowly so we can master the discipline of problem solving by stepwise refinement, the magic of the black box and the power of pseudocode. Our second stop will be to learn the art of the flowchart, to track our slow, logical thought, and to build the reflex of modularity. With these thinking styles on board, we'll turn to learning the binary arithmetic, Boolean algebra, and the finite math that we'll need during our journey. And then part one of the journey finishes with a module on automation. We'll look at the history and fundamentals of automation and work our way from music boxes,
Imagine there's no heaven,
automata, tea kettles, and microwaves, to landing airplanes on ships and understanding the basics of PID controllers and the math of keeping a drone flying where you want it to fly. Next comes an interlude in the land of tools. We will add 3 kinds of structure to our repertoire. In data jigs, we'll learn how data structures make complex information easy to manipulate and think about. In iteration, we'll learn how to use repetition to solve problems reliably, and in patterns, we develop tools for generating and recognizing complex structures in data, in art, and in life. Our last stop in tools is an introduction to APIs, application program interfaces, the magic wands of the computational universe. Once you're initiated into their use, nothing will ever be the same again. And after foundations and tools, we'll get to visit the land of applications, where we'll look at how automatic computational machines do the things they do. How do machines keep secrets? How do machines see? How do machines learn? This course is totally online, and for me at least, that's a big experiment. The learning flow in each module will go something like this. We'll start with an overview that explains the terrain ahead, connects it with where we've already been, and previews the resources we'll use, as well as laying out the learning outcomes that the module is expected to achieve. Each session in the module will consist of readings, watchings, and doings. One last thing, the question everybody asks, do we need to know how to code already? Will we learn how to code? Well, no and yes. The course has no expectations that you've ever coded before. We will learn styles of thinking that underlie coding in any language, and we'll learn a bit of JavaScript. Not enough to say that we're JavaScript coders, but enough for you to become one with a little bit of further study. So that's about it. Have a look at the course outline and the course materials and other information at the end of the video. And I look forward to working with you. I think we'll have some fun. I'll see you soon.